Welcome back, ladies and gentlemen. This is Marcus Anderson for Keller Community College. In this video, we're going to take it in three quick parts. The first part is going to write exponential expressions as radical expressions and simplify them if possible. The second part is going to be reversing the application of writing radical expressions as exponential expressions. And then we're going to simplify some perfect roots, which should go very quickly since the roots work perfectly, actually. So let's talk about writing exponential expressions as radical expressions. So this is an exponential expression because the exponent is given. We want to write it as a radical expression, and I want to remind you that if you have any base raised to the m power taken to the nth root, this can be rewritten as inside out. So inside out. Inside out. So here's what we're going to do. We're going to write this as 2 to the first power under the third root. So this is the cubic root of 2. And these are equivalent, and this is as far as we can go. This problem is going to be 2x under the fourth root taken to the seventh power. But you may want to be careful that you should always try to simplify these expressions if possible, which means that 4 goes into 7 once, so you would have a 2x multiplied by the fourth root of 2x raised to the third power, because the 4 fits into the 7 once with 3 left over. So this becomes a simplified version with 2x on the outside and then a 2x cubed on the inside of the fourth root. Now you could have actually simplified that back here and made this problem into 2 to the first power, or sorry, excuse me, 2x to the first power multiplied by 2x raised to the 3/4 power, because 1 and 3/4 adds up to 7/4. So this is another way to do the problem to get that equivalent answer. In problem number 13, one of the tricky things about it is a lot of people would write the -9 under the radical. But it is in fact the a that is the only thing under the radical, because the 2/3 power belongs to the a itself and not the -9. You'll note that in problem number 12, the parenthesis was around the 2 and the x, but here there's no parenthesis around the -9 and the a, so you have to basically assume that the a is the only thing raised to the 2/3 power, so the 3 goes on the outside, the 2 goes on the inside, and the -9 is in front. Nothing is modified or adapted from that. In this problem, there's a couple different ways to go about it. My personal preference is to do the power-to-power rule, which means that you would raise these to their higher power using this rule. If I have a to the m raised to the nth power, I would multiply the m and n together. So I'm going to use that rule here, and that way I get x squared multiplied by 3/5, and then I'd have y squared multiplied by 3/5, and 2 over 1 times 3 over 5 is the same thing as 6/5. So what I have here is I have x to the 6/5 times y to the 6/5, and there's a lot of different ways now to go about and take this into what you need to do for simplifying this expression. Because one way you can do it is see that 6/5 is 1 1/5. And again, to see it as 1 1/5, this would give me the 1 and the 1/5 x. This is the 1 y and the 1/5 y right there. And, you know, obviously the 1 plus the 1/5 makes 1 1/5. So this would give me my xy out in front. And then my fifth root, I have 1x and 1y. Because the 1/5 and 1/5. Now, another way I could have done this too is I could have, now again, this is one way to do it. Another way to do it is to put them both under the fifth root and have x to the 6th, y to the 6th, and then using the information from our previous video, 5 goes into 6 once with 1 left over under the fifth root, and then 5 goes into 6 once with 1 left over in the fifth root. And that's problem 14. All right, so 15, 16, 17, and 18. I did modify this from some of the worksheets, so if you don't have the parentheses there, please add them, because what we're going to do is convert these into radical expressions. So again, using our information about indexes and inside-out exponents, this is going to be 15 to the 1/2 power, or inside out. This here is going to be, the negative stays in front here, this is going to be 4x in parentheses raised to the inside out, so 4/3. Over here, there is a parenthesis around this binomial, so this is a squared minus 8 raised to the 1/2 power, and this is unfactorable, at least with using whole numbers here, so we're going to just leave it at that. And this here is 3x times y raised to the 1/4 power. You'll note that I won't need parentheses here, since the 1/4 is only acting upon the y, so this would be an acceptable way to write the answer. In our final part, we're going to look at simplifying radical expressions that have very nice perfect powers. So if I look at the square root of x to the 12th, 2 fits into 12 6 times. Another way to look at it too would be to write x to the inside out and then simplify that to the 6. The negative stays out in front, 2 goes into 14 7 times. Down here, the negative stays out in front, 3 goes into x to the 12th 4 times, and 3 goes into y to the 6th twice. And then for this fifth root problem, we've got x squared y to the 5th, because 5 goes into x to the 10 twice, and 5 goes into y to the 25th 5 times. For our final 4 problems, these go again quickly because they are perfect problems with no remainders or leftovers. 3 goes into a negative 8. Now the negative under the cubic root stays a negative. You'll note that the negative is not actually with the 8 to the 9th power, so the cubic root of negative 1 is technically negative 1, so we'll just bring the negative outside of the problem. Some of you may have just wrote a negative in front of this without even thinking about it, but for negatives under a odd radical, you just move it in front, because you can take the negative inside of an odd radical or an odd power there. Okay, so 3 goes into a to the 9th 3 times, so there's a cubed, and 3 goes into b12 4 times. The square root of 144 is 12, and as another reminder, we are not considering any of these values to be made from negative values, so we're not going to look at plus minuses in any of these problems until we get to the quadratic chapter. So then we also take a look that 2 fits into x to the 12 6 times, and 2 fits into the 16 8 times. Down here, x to the, almost wrote a y first, x to the 3rd power, y to the 5th power. The negative stays out in front. This is a to the 2nd power, b to the 3rd power, because 4 fits into 8 twice, and 4 fits into 12 3 times. All right, thank you for watching the video. If you have any questions, please send me an email. Thank you.